To appreciate the engineering behind iTrack Advance, you have to look at its predecessor. The iTrack 250A was a masterpiece, pioneering and proven. But technically, it was a challenge. Handling a 220 micron catheter with forceps is like trying to push a slippery wet noodle. So the goal wasn't to change the microcatheter, but to build a delivery system around it, translating the sophisticated microcatheter into an intuitive, efficient experience for the surgeon. Now, when designing a handpiece to advance or retract a microcatheter through Schlemm's canal, there are two common mechanisms: a scroll wheel or a slider. A scroll wheel works well for short, static placement, like a stent, but in a 360-degree canaloplasty, it forces you to scroll, lift, and reset, a jerky motion that destabilizes the hand. That's why the iTrack Advance uses a single-stroke slider for optimal stability. But covering the entire circumference of Schlemm's canal, which averages 40 millimeters, in one stroke is an extensive range of motion. To keep this motion comfortable, the handpiece design of the iTrack Advance utilizes a 2-to-1 gearing ratio. This means moving the slider just 20 millimeters advances the microcatheter a full 40 millimeters, keeping the movement within a comfortable, stable range for the entire procedure. But here's the risk with gearing systems. Usually, gearing numbs the sensation, but the iTrack Advance is engineered to maintain a direct mechanical link. If the microcatheter tip hits a blockage in the canal, that resistance travels instantly up the shaft of the microcatheter, letting the surgeon feel the obstruction directly in their finger or thumb. This definitive signal lets you stop and deliver 1 to 2 clicks of viscoelastic to help navigate past the obstruction, rather than forcing the microcatheter forward and forging an unintended pathway. Of course, stability also comes from comfort. To eliminate awkward positioning, the design is symmetrical and non-prescriptive. Whether the surgeon uses their left or right hand, a pen or overhand grip, the handpiece balances perfectly. The surgeon can even rotate the nozzle of the handpiece 360 degrees to optimize precise placement of the cannula tip, fine-tuning the angle of entry to suit the patient's anatomy. This allows precise alignment of the cannula tip with the canal while maintaining a comfortable, neutral grip. Finally, there is the precision of the goniotomy. To access the canal, the goal is to remain as minimally invasive as possible. While the cannula tip creates the initial opening, its spatulated design effectively cradles the microcatheter. This shape eases the catheter into the canal at a trajectory that traces the natural anatomy, guiding it smoothly into position. Gearing, ergonomics, and access. The handpiece isn't just a plastic shell, it's a precision instrument. It is designed to translate the complexity of the microcatheter into simplicity for the surgeon, turning difficult maneuvers into stability and technical skills into consistent clinical outcomes.